All right. Hello, everyone. It has been some time since I did my last one of these. It is great to be back talking with you all. So the topic for today is DynamoDB. It is going to be quite a dense session. So I'm not going to take too long on this intro. I just want to walk quickly through what we are going to build today and take you through the roadmap for our integrations with DynamoDB. So let's get started. So in this session today, we're roughly going to cover this, which is going to take us basically end to end from an existing DynamoDB table through to a user-facing application. So we'll start on the left with a DynamoDB table. We'll go and we'll enable DynamoDB streams, which will capture change data in the DynamoDB table. And then we'll enable point-in-time recovery, which will help us with historical data. So that will push exports into S3, and we can use that for our bulk loads of existing data. We'll add a AWS Lambda function, and that will be triggered by the stream and by the exports, and that will push data towards Tinybird. To bring the data into Tinybird, that will be pushing towards the Events API and the Data Sources API. We'll then look at how we index and analyze that data once it's landed in Tinybird. We'll then publish some API endpoints out of the analysis that we do. And then we'll see how we integrate those API endpoints into a user-facing app. And so quite a lot to cover. So just very briefly on the left-hand side of that, the integration with DynamoDB and what that looks like. So a lot of the people here today are probably here and coming from Rockset, right? So you're probably a lot of previous Rockset customers looking for a new place to go. So obviously there was a native connector in Rockset, and we'll talk about what's coming for Tinybird there. So in the short term, what we have is an open source connector that uses AWS Lambda. So if you are looking to start a POC and start evaluating Tinybird and working with data immediately, this is going to be the option for you right now, and that's what we're going to use in today's session. So that's open source. It's on this GitHub link. Let me zoom in a little bit. And you'll basically, all the code for the Lambda is there. You can go take that, create the Lambda function. It runs in your account. You own it, do what you want with it. Now, this is what the kind of short-term solution. So going into the long term, obviously, Rockset had a very, very attractive native DynamoDB integration. And that's basically where we're going. So we've already started work on it. And in the next 1 to 2 weeks, we're expecting to have a beta. If you do want to get beta access to that connector, you can either email us on support@tinybird.co or join our community, tinybird.co/community. Just let us know that you're interested in it. We'll add you to a list and we'll let you know as soon as that's available. Basically, the experience that you would get out of the Tinybird native connector will be very similar to the experience that you'll have had from the Rockset native connector. So you'll go to the Tinybird product, you'll set up a little bit of configuration, give us an IAM role or some credentials, pick your tables and all of that, and then everything will just kind of work. You'll notice some similarities between this short-term open source one that we're using today and the long-term native connector we'll have. And that's basically that the way we integrate with DynamoDB will still be through the DynamoDB streams and point-in-time recovery. So, all of the work that we do today, and if you do adopt this, all of the work that you do to configure it will be reused for the native connector. So unless there's any questions on that, that's the intro, and we'll just we'll get started. No questions so far. Okie doke. So in AWS, we've got an existing DynamoDB table. I'm assuming that most people will come with an existing table. So this has got a little bit of data, nothing too crazy in it. And the first thing we need to do, if you haven't already, is enable point-in-time recovery. So just go to the backup tab on your DynamoDB table and find at the top point in time recovery. Mine's already enabled. If yours isn't, there's just this little edit button. Tick this box and then save, and that enables it. And then you'll want to go to the Exports and Streams tab, go all the way to the bottom and find DynamoDB stream details, and then just turn that on. You'll get an option for what view type you want, and just pick the bottom one, which is new and old images, and then turn on the stream. That doesn't take very long. There we go, it's done. So once you've done that, what that means is that any changes that now happen to your DynamoDB table, so any inserts, any updates, any deletes, those will actually be captured as the change events onto the stream. Any change events that happen prior to enabling that stream, you will have to bring from doing the bulk export, and then any changes that happen after enabling the stream, you'll be able to get from the change capture stream. So that's the only changes you need to do to your DynamoDB if you haven't done them already. You will need an S3 bucket for your exports. Just a general, normal bucket. Make sure it's in the same region as your DynamoDB table. I've already got one created here, so super easy to set one up. The next thing to do is IAM. So you need to set up a policy and a role, which is going to be attached to the Lambda to give the Lambda the appropriate permissions to work on the AWS services. So to start with, let's create a new policy. So go to IAM, go to policies, create a policy, go to the JSON editor, and then super simple, just go to the GitHub repo and go to the CDC folder, find the Lambda policy JSON, and we're just going to copy and paste it. So just hit copy, come back to IAM and paste that in. I'm not going to go line by line through this, but basically it's giving some S3 permissions. It's giving permissions on the DynamoDB stream. It's giving some permissions on the DynamoDB table itself, some CloudWatch log permissions, and some permissions on Secret Manager for storing your API key. Now, the only thing to change in this is the S3 bucket name, which would have been useful if I had kept my S3 tab open. So I'm just going to go back to that so I can copy and paste. And we will just replace this. And that's it, right? That's the only change you need to do to the policy. Obviously, if you want to customize this and you're familiar with IAM policies, feel free, but this is just a template to get you started. So we can hit next and just give it a name and create. And that's all there is to it. So the next is the role. Again, very similar. Create a role. You want to pick AWS service, pick the Lambda, assign the policy you just created, give it a name, and create. And that's it. That's the IAM setup done. So nothing more than that. So now we can get started with the Lambda. And we're going to create a new function. So pick author from scratch, give it a name. Now the runtime you're going to want to pick is Python 10. So we've supplied in that repo some Python code. Keep your architecture as x86, and then the only thing to change is your execution role. So expand the little option, go to use existing role, and then pick the role we just created and create function. So once that's done, we need to go and update the code. So again, go back to the GitHub repo and find the Lambda function Python file and just copy and paste. So come back to the Lambda and paste it in. There's nothing to change in this. It's all parameterized. So you can just paste it in and leave it. I'm not going to go line by line through the code, but it is open source. Feel free to go through and if you need to make changes, it's up. Yeah, you're welcome to as well. Make sure you hit deploy. If you don't hit deploy, it won't work. And this will go green once it is deployed. And then we need to set up the environment variables and the triggers. So we'll start with the environment variables. There's 3 that we need to add. And these are documented in the guide. So if you go to our documentation, go to the guides tab, there's a guide for DynamoDB. It covers pretty much everything we're talking about today. I'm just going to copy and paste the environment variable names like this, and then I'll explain what they are quickly. Easier than me making some typos. So the three that we've got is the token, the prefix, and the endpoint. So the token is going to be the Tinybird auth token that is going to auth the Lambda making API calls against Tinybird. The prefix is going to be a prefix that is prepended to any table names that are created in Tinybird. And the API endpoint is your Tinybird API endpoint, which is the regional API endpoint for the region that you're using for Tinybird. So for the prefix, I'm just going to use DDB underscore. And then the other two, we need to go into Tinybird and actually pull them out. So in my Tinybird workspace, it's empty. The easiest way to get your API endpoint is create a new data source, go to Events API, and then just copy and paste the start of the URL up to v0/. And we'll come back to Lambda and wrong one, paste that in there. So then we need the token, and we'll go back to Tinybird, go to tokens, we'll create a token, and we'll call this DDB token. And then super simple on the permissions, next to data source scopes, just tick enabled, and then save. Copy that token, come back to the Lambda and paste that in. So thing to note here is I'm just pasting that in plain text in my token, in my environment variable. If you want to use the secret manager, you can, and that is documented in the repo. I'm not going to use that here, but you can if you want. And then hit save. So that's the environment variables done. So next is the triggers. And the triggers is what's going to tell the Lambda to actually fire. So we'll add the first trigger, go to S3, pick our bucket, leave the event types as all object create events, and the prefix as exports, suffix as .gz, so that's for gzip, and just tick the recursive invocation warning. Hit add, and basically what this means is that when you trigger an export on your DynamoDB table, that will create a bundle in S3, and that create event is basically registered as an S3 event notification that will trigger the Lambda, which will pick up the file and forward it onto the Tinybird data source API. So the next step is add another trigger and pick DynamoDB, choose the DynamoDB table. Now, pretty much all the rest of these options you can set to whatever you want. I'm just going to do some same defaults that you can copy if you want, but you can pretty much use what you want. So I'll leave the batch size as 100. I'll put the starting position as trim horizon. Batch window, I'll put as 5. Retry attempts as 5, and split batch and error. Again, pretty much set this as you want. And with that done, that's pretty much our Lambda finished, right? So what that DynamoDB trigger will do is whenever you do a create, update, or delete operation in DynamoDB, that change will go through into the DynamoDB stream that we configured at the start. And that event will trigger the Lambda, and that will forward those events onto Tinybird over the Events API as a stream. Okie doke. So I'm going to quickly show you how you do a historical import, but I'm not going to wait for it to finish because it can take 20-25 minutes for the whole operation on the AWS side to complete. And we could just be sat here watching a loading circle for a while. So all you would need to do is go to exports and streams on DynamoDB table, hit the export to S3 button, pick the bucket, put that prefix in again, and then just hit export, and that's it. So that'll sit there as exporting. It can be pretty quick, 5 minutes, or it can take 25 minutes, so I'm not going to wait for it. but that will just go and drop a batch export of your historical data into S3, trigger the Lambda, forward it onto Tinybird. Right. So with that done, that's pretty much everything on the AWS side finished, and we can actually start to look at our application doing CRUD operations, and then how that ends up being sent to Tinybird, how we deduplicate and handle upserts, and how we build analytics. So to do that, I've got this little application. Doesn't look too beautiful, but it's just a little thing that will let me do some CRUD operations on DynamoDB. So I've got some toggles at the top here, which lets me impersonate various different end users. So if you imagine that, we're a flight reseller, let's say, and we've got end users who are the people actually booking flights, managing their flight, canceling them. And then we also might have enterprise customers who are the airlines who want to be able to see the performance of their business. Right? They want to see how many people book flights and over time and the options they picked and all that kind of stuff. So I've got my users, and then I've also got the airlines who want to be able to see analytics. So right now, I can start sending individual rows, and this is just going to send some fake data of somebody booking some flights, and that is just doing a put item onto DynamoDB. But obviously, that should also be picked up on the DynamoDB stream, which should trigger the Lambda and forward that on as an insert event into Tinybird. So if I come back to Tinybird, you can see that my empty workspace now actually has a table, and so those events have already started arriving in Tinybird. And you can see that they were insert events, and I've got all of the metadata that comes from DynamoDB, and then I've got my new image, which is actually my item, the payload. So these are just inserts, and if I go back to my app, I can, for example, do an edit. So if I edit the amount of bags, I can change that to 3. So that's doing an update on DynamoDB, which then should be captured, and it comes through as a modify onto Tinybird. And again, I can go back and I can cancel that one. So that's going to go ahead and do a delete in Dynamo and come back, and I get my my remove. And so those are the 3 main types of events that you'll get from Dynamo: insert, modify, and remove. When the backup, the S3 export is complete, those will come through, and the event name will be snapshot, but they're effectively just all of the rows that already existed. Cool. So now, this is good, right? I'm getting my CDC capture, but it is just an append log at the moment. So this is just appending every change. Obviously, if I want to start doing analytics, I don't actually want the append log, because that's going to affect my stats. I really just want to see what the state of the world is right now. So we're going to need to handle the upserts and the deletes. So I'm going to do that by using a Materialized View. And if you're coming from another database, a more traditional database like a transactional or a warehouse, Materialized views tend to work as batch operations that you schedule, and you run it and it goes and replaces the entire table state. That's not how they work in Tinybird. So Materialized views in Tinybird are event driven and incremental. So what that means is, as you insert new rows, it triggers the Materialized view to process. And then when it processes, all it does is take in the new data that came in and then work out what state in the table needs to be updated, and then leaves everything else as it was. So they are both real time and very, very efficient. So for our Materialized view here, I'm just going to call this dedupe and call this top node Materialized view. And I'm just going to leave it as a select star, right? Because we don't actually want to change in our data, and we want to select everything. But remember, because it's event driven, it's not selecting the entire history when it's just going to select the data that comes in an insert operation. So we're going to create the materialized view. And then in the sorting key, I'm going to take out new image and old image and just leave transaction ID and then go to advanced. So I'm not going to go into too much detail about what these engines are, but by default, everything is a merge tree. What we're going to want to use for this is a replacing merge tree. So the replacing portion of it, basically what it means is it is going to look for a uniqueness in rows, right? It's going to look for an ID of a row and assume that a row with that ID should be unique. And then if it sees three rows that have got the same ID, it's going to assume, hey, I need to deduplicate those. I need to replace them. And it does that by using a combination of this sorting key. So in this case, we're going to use the transaction ID, which is the partition key of our DynamoDB table, and the engine ver field, which is the version. So in our case, we're going to use approximate creation date time. And so what that's going to do is, if it comes, if we find three rows that have got the same transaction ID, we're going to look at them, look at the approximate creation date time and pick the latest one, because that is the one that, the other one should be deleted because that's the latest one and we only ever want the latest copy. So I will give this a name, hit next, and then on this page, we're going to pick previous and new data. So that is going to take all of the rows that we've already ingested and run them through the materialized view, and then it's going to keep up to date with any new insert operations. Okay. So that's created. So now what we've got is two tables. We've got our raw append log. There's a question come in, which there are a bunch of other Tinybirders in the chat. So I'm going to hope that someone else in the chat can handle that question at the moment. I'm going to carry on. So we've got two tables. If somebody doesn't get to that question, I will come back to it. We've got two tables, and so we've got our raw append log and we've got our deduplicated table here, which is being fed by that materialized view. So obviously we want to be able to start analyzing our data now. So I'm going to create a pipe off the deduped one. But quickly, I want to talk about that replacing merge tree and how that actually works. So although materialized views are handled, they're updated by an insert operation, the deduplication operation is asynchronous, right? It's an asynchronous background operation. And so it is not triggered by the insert operation happening, which means that actually at query time, you can't guarantee that that asynchronous operation has happened and finished. And so you could still have duplicates, i.e. rows that have not upserted. And so we need to be able to handle that. So let me show you what that actually looks like. If we go back to our app and we insert a new row, and I'll just copy that ID and do where key transaction ID is equal to the ID. So there's the insert operation. Now, if I go back to my app and I edit that one and I change that to 4, and come back here and hit run, we've actually got the two rows. So, remember this is coming off of our deduped one, so we would expect that to be deduped, but we can't add the asynchronous operation hasn't happened yet. So to handle that, all we need to do is add final to that. And basically that just means at query time, that guarantees that operation has definitely happened. If it hasn't happened, do it. Obviously, most of the time it has happened. So this is just like a little catch if it hasn't. So that's great. That does the deduplication. But there's one other kind of gotcha to keep in mind, which is if I do a remove, so I delete that row, and I come back here, I've already got that remove and it has deduplicated, but I'm actually seeing a remove, right? Which makes sense, but also actually it's been deleted. And so I would expect to see nothing because it's been deleted. And so you also need to handle that deletes. And that's pretty easy. We can just add another part for where and say event name does not equal remove. And so that goes away. And that's, the result that we would have expected, which is that we see nothing because it's been deleted. So if I delete that part and just make that the final query, like that is now what we actually want to see, right? This is our final inserted, upserted, and deleted data. Now, obviously you don't want the additional cognitive load either for yourself or for the rest of your team as they're trying to build business logic downstream and build APIs and do analytics, having to remember to do final and remove deletes at the end. So we can actually just do a super easy trick, which is basically make this a view. So if I say this is final event view and call this view, and then create an API off of that. And then when I actually go to create a new pipe and do something, instead of talking to my dedupe table, I can just talk to that final event view, run that, and that's handling all that logic for me. And if I look at the explain pan, you can see what's happening there. It's basically just taking that in as a little subquery. So nobody else actually ever needs to think about doing any of that dedupe logic. Now, obviously, I'm getting a bunch of fields in here that most people probably won't care about, like it's all of the DynamoDB metadata. So in here, I can also just handle that and take that new event, that new image as event, and then I've got my JSON payload, right? So now I've just basically just got a single column, which is a big string, and it's just my JSON payload. So now when I want to start querying that, I will just get my JSON payload. So that's kind of the tricky bit, that's the AWS config done. It's the deduplication and deletes handled. So now we can actually just start working with our data, right, and start doing some analytics. So obviously, because this is just a JSON payload, we need to start, we don't have a schema for it, so we just need to start referencing fields within the JSON and querying it. Now, there's a couple of different ways that you can do that in Tinybird, a couple of different functions that you can use. I'm going to use JSON extract functions. There are some others, but the JSON extract ones are just super easy. So if I do a JSON extract, the first parameter is event, which is the payload column. The second one is basically the JSON path that I want to extract. So let's say airline. And let's treat it as a string. So I'm getting the airline field that's coming from my data. So I mean, let's do this with a purpose. Let's actually build something. So on this dashboard tab, I want to start filling in some of these little widgets. So an airline wants to know what their total flights are, which is a really super simple aggregation. It's just a count. So let's call this total flights by airline. And we'll start by doing our filter. So we've already extracted our column. One thing that we want to do, right, is that each of those tabs is actually a specific airline. So we don't want one airline to see the total flights of every airline. They just want to see it as their own. So we'll add a dynamic parameter to this so that when we publish an API, you can just pass the name of the airline as a query parameter on the API, and that will come through to the query dynamically at query time. So we can say, where airline is equal to string airline. We'll say Brian Air is the default, and so that's going to do a filter. And I'm just going to send a bunch of fake data through because we don't have any Brian Air rows. Still don't have any Brian Air rows. Come on, give me some. There we go, got some. Right. So I've done a filter. I don't need any other columns to do a count. So instead of writing this entire API as just one massive query, I'm going to break it down into individual nodes. And that basically just lets us chain SQL queries together. So in the second node, I'm going to query filter, which is my first node. So here I can just do I'm going to select the airline, and I'm going to do a count as the total and group that by airline. And so now, it's super basic, but that's my aggregation, right? I'm doing a count by airline. And so all I've done is extract the fields I need from a schemaless JSON payload and do some analytics on it. And so if I want to turn that into an API, I can just go to this node, create API endpoint, and bang, there's my API. I can copy and paste that URL, go to here, and HTTP, get my JSON response. So let's actually get that integrated into the app. So in this demo, I've got this little total flights widget, and I want that to actually hit the API and get the value. So by back in the Tinybird UI, I'm just going to hit this JS button, and that will give me an auto-generated JavaScript snippet of how to use my API. I'm going to copy that and come over to the React code for my app. So I've got a function here for get total flights, which has got nothing in it, and I'm just going to paste that in. And so, this is all pretty simple stuff, right? It's just doing a fetch to this URL and getting the JSON result. So that's my API URL. This is where I'm setting the query parameters for my dynamic variable. So I'm going to replace that with airline so that when I switch tab, it will get filled with the name of the airline. It's adding in my token there. Obviously, you'd want to do something more secure than just hard coding your token in there, but that's fine for now. And then here, there you go. Look, Copilot is doing some of the heavy lifting for me. And that is just going to then set the state to the total value that's coming off that API. So if I save that and come back to my little thing, they'll see it's already done it, right? So total flight is now 5. And if I switch between all of these different tabs, that's hitting the Tinybird API and getting the latest result. So if I inspect here and go to the network tab and start moving between these, you can see that every time I do that, it's hitting the Tinybird API, getting response and showing it. So not caching it or anything like that. That's hitting the API, running the query behind it, returning the result. And so, I can sit here and send a couple batches of data, and we'll see those values update. I mean, it didn't take less than a second or something for those new values to start showing. And that is, again, sending the batch inserts into DynamoDB, CDC'd into Tinybird, and then we're hitting it. So they're able to be queried very, very quick. Great. So I mean, that's one widget. I'll just show you, one other widget, which I will just duplicate this pipe. So let's say, what we want to show is a time series, right? We want to show sales over time. So we'll do another JSON extract, and this time we'll take the timestamp. Cool. And then I actually don't want that as a string. I want that as a date time. And I also don't actually want that as a full date time. I just want it as a date. So I will just cast that. And so I've just, again, got my airline and I've got my date. And then here I'm just going to add that date in and group by the date and airline. And then I'm also going to do a or by the date and airline. So I've got a time series, right, which is just the amount of sales that an airline had per day. So I'll turn that into an API endpoint, get my API. Now I could just go and pick a charting library and manually write the JavaScript and do all that. But I can use Tinybird charts and do that even quicker. So I can just go to this charts tab, create chart. I'll call this, what do I want to call this? Here's my stub component. I'll call it that. And I want that to be a line chart. And my data is going to use total as the categories and date as the index. That's my chart. Hit save on that. Go to this code tab. I'm just going to copy and paste this auto-generated React component. Paste that in this file. Save it. Go back to my app. And There's my chart. So it's doing exactly the same thing, right? And this could be a custom chart library, and you hit that API yourself. But that just lets me put a chart in super quick. And again, it's all hitting the APIs in real time, and it's showing the response. So if I send some more batches, we'll start to see these charts update. There. So, I mean, the other thing to show, so for example, we've got 34 flights on Ryanair. Do I have any? No, let me send some more until I get Ryanair. Hey, there we go. So we've got 35 flights on Ryanair. If I go through and delete this Ryanair flight, these are all my copyright-friendly, trademark-friendly names for airlines that obviously don't exist. So I've deleted a row, and I go back here, and I've got 34. So that's just to show that that delete operation has come through, been CDC'd into Tinybird, and we've handled that delete, and the query time is still super quick. And yeah, that's pretty much it. Everything that I've got to show, really. So, coming back to this, kind of what we've seen is we've started with a DynamoDB table. We've done some CRUD operations. We've set up streams to capture any of the changes that happen. And we've used point-in-time replication to capture the historical data. We set up a Lambda that will capture that, push that to Tinybird. We've indexed and analyzed that data. We've published some APIs, and we've embedded those APIs into a user-facing app. Now, again, we're using our short-term open source connector here, using a Lambda that you run in your account. And in the next couple of weeks, we'll have a native connector, which if you look here at create a new data source, these are our native connectors, and it will just we'll basically have a DynamoDB button here. And here where you set up some config options, it'll be very similar. You'll set up some config options for DynamoDB, and then you won't have to do any of that messing around with Lambda. Yeah, so that's everything I had to show. We are a little bit ahead of time, so if there are any questions, we can take some time for questions. Otherwise, I will keep it short and sweet and wrap up. So we had one question that looks like it's been answered. Thanks for the demo. On the AWS side, do you have any proposed patterns for handling any failures in Lambda? Did you pair the stream with some DLQ? So on the failures, and this is basically what Dan has responded to, but pretty much what you can do is in the Lambda configuration, you can set it up to forward failures somewhere. So what you can do is you can put like an SNS topic in there and have an SNS topic send out some notifications that a failure has happened, and then you could do kind of what you want with that. Send it into Slack to get a notification. You could send those notifications into Tinybird and do analytics about your failures if you want to get fancy with it. But yeah, if you have something specific in mind for failures, obviously we can. It's an open source connector. We can go and add some stuff to it, and if you let us know what you're thinking about, we can help you with that. And then yeah, cool. So I'm not seeing any other questions at the moment. Cool. So if there's no other questions, then we'll end it there. But I hope that was helpful. And again, if you are interested in the beta of our native connector, email us. Let me get that on screen again. That's support@tinybird.co, or join the community at tinybird.co/community. Just let us know, hey, I'm interested in the DynamoDB native connector, and we'll let you know as soon as it's ready. But also let us know if you do want to start working with this open source one. We can help you get it set up. We're happy to help you through a POC, and when the native connector does come out, we can help you migrate towards that as well. So I think that's everything. Thank you for joining and listening. I hope that was useful, and Well, have a great rest of your week and weekend.